The title of my presentation is Multisensory Benefits when Grasping Under Visual Uncertainty. In everyday life, we often grasp objects we already hold in the other hand. In such cases, the size and position gathered through both haptics and vision leads to a consistently superior performance compared to movements guided by each modality alone. In a previous study, we showed that such multisensory advantage stands for the integration of vision with haptic position cues more than with haptic size cues. However, it might be that the visual haptic integration occurs both at the level of position cues and at the level of size cues, but with the more reliable visual size cue completely dominates over the haptic size cue, making it hard to determine whether the haptic size information is thoroughly integrated. In this study, we aim to identify whether haptic size cues are integrated in multisensory grasping by modulating the quality of vision. The quality of visual information was manipulated by positioning the to-be-grasped handheld object either in the central or peripheral vision. In a haptic condition, the object was not seen, but only held by the left hand. In a visual condition, the object was only centrally seen. In a visual haptic condition, the object was centrally seen and held. The last two conditions, that we called peripheral vision and peripheral visual haptic, were identical to the visual and visual haptic conditions, but critically the object was in peripheral vision. In this figure, you are going to see what we have found. We plotted the peak of grip aperture on the x-axis and the slope of the peak of the grip aperture on the y-axis that indicates how sensitive is the grip aperture to changes in the object size. The size of the dots correspond to the peak velocity values. Larger dots on the top left corner correspond to a very good performance. This is what we found. In the central vision conditions, we have replicated our previous findings. Visual haptic conditions showed smaller grip aperture and a higher peak velocity than the unisensory conditions. The slope of the grip aperture in visual haptic condition was the same as in the visual only condition. In peripheral vision, we have also observed an increase in performance in the visual haptic condition. Grip aperture was smaller and peak velocity was higher than in the unisensory conditions. However, contrary to what we have observed in central vision, also the slope of the grip aperture improved substantially. This could be taken as a sign that haptic size was now also included in the integration process. But it could also be that this is a byproduct of the availability of haptic position cues and thus haptic size does not play any role. To tease apart the role of haptic size and position in peripheral vision, we ran a second experiment where we reran the peripheral vision and peripheral visual haptic condition, with the addition of a third condition that we called peripheral visual haptic position. Here we remove the haptic size cue while grasping in peripheral vision. In such condition, participants were holding a pose that supported the object. So we replicated the result of experiment 1. Adding haptic information in peripheral vision increases the peak velocity, reduces the grip aperture, and improves the slope of the grip aperture. However, different scenarios were hypothesized for the peripheral visual haptic position condition. If haptic size plays a role in peripheral grasping, we would expect improvements in grip aperture and velocity, but the slope should be close to what we found in peripheral vision because now the haptic size was not provided. On the other hand, if the improvement in slope is just a byproduct of the integration of only haptic position, then the condition without haptic size should be very close to the peripheral visual haptic results. We found that withdrawing the haptic size did not affect the peak velocity and peak of the grip aperture. However, the haptic size was fundamental to properly scale the grip aperture. So we conclude that haptic position plays the major role in multisensory grasping, either when the handheld object is in peripheral or central vision. However, the haptic size cues are still integrated with vision, but their contribution is mainly visible when vision is disrupted. Thank you very much for your attention. Our lab is hiring a new postdoctoral associate, so if you are interested, write to Robert Volcic at nyu.edu. Thank you very much.